Hi, my name is Frank DeCellis. I'm a professor in the School of Technology in the Electrical and Electronics Engineering Technology and Technician programs, and I'm also the Year 2 coordinator. Today we're going to take you on a tour of all of the labs that are used by the Computer, Electrical, and Electronic Engineering Technology and Technician students. It's a 3-year program for technology, it's a 2-year program for technician, and the computer, electrical, and electronic students share a common first year that they're all together. So you're able to, at the end of first year, if you decide that you want to switch streams from one to the other, you're still able to do that. And also the way the program is configured, that if at the end of 2 years, you are a technology student, but you don't feel you can continue, then you can graduate with a technician diploma, or if you're a technician student, you can decide to continue on into the technology stream. So we're going to go through all of our labs. We're going to do a few quick demos. Our students, after graduation, get jobs in power distribution, in maintenance and industrial settings, in industrial controls, industrial automation, general contracting, engineering consultants. They get into communications, they get into wireless communications, into radio, into the engineering part of the back end for media. We also have students who are working as PLC programmers. We have students who are in fabrication, maintenance, support. There are so many roles. A lot of our computer students are working in IT departments for very large companies. We have some working here at the college as well, but they are equipped to work in a variety of IT settings to support medium and large-sized businesses. So people always ask, like, there's not one specific job that this leads into. For an engineering technologist and technician, if you think about it, every process, every service, every product needs to be conceived, it needs to be designed, tested, it needs to be marketed, it needs to be manufactured, it needs to be sold, it needs to be installed, supported, upgraded, maintained later on, and those products need to be upgraded as time passes to have more features and everything. Every single step in that process involves engineers, engineering technologists, and engineering technicians. So there is no one field that you get funneled into after this program. Whatever your strengths are, you can apply them into different areas of engineering and engineering technology and technician. So let's go for a walk, and we're going to go through the department, and we'll check out our facilities. So now we're in L118. This is where I spend a lot of my time. This is the Electrical Fundamentals Lab, and it's used by all first-year students in the Computer, Electronics, and Electrical program. It's also used by our first-year students in renewable energies and our electrical apprentice students. So what goes on in here is we do all of the labs for Electrical 1 and Electrical 2, so you're in here every week performing experiments. Every station is equipped with the same equipment. So they all have a DC power supply, a function generator, an oscilloscope, and a digital multimeter, as well as a computer at each station. So we can do our simulations, and you can enter in your data for form-based labs. Every student does get their own kit with parts, so you become very familiar with what L118 and L119 that we'll be going into later. Welcome to L119. So similar to L118, this is our first year fundamentals electronics lab. So in here, you will find our computer, electrical, and electronics students, all first year. You will also find year 2 and year 3 electronics students, and you'll find our sometimes our apprentice students and our renewable energy students. So in here, we go through the fundamentals that you learn during electronic devices and various electronics courses, including operational amplifiers and some communications courses. This is just an example of one of the simulations that you would work on during your program. So this is going to simulate a machine that is surrounded by a fence where the fence needs to be closed for the machine to operate. So what happens is we've simulated the fence opening, and the machine stops, and when the fence closes, the machine can continue again. So this is just a simulation of that fence gate. And then if the E-stop is pressed, the emergency stop button, everything else is dead. Everything else is dead until the emergency condition has been cleared. We've disengaged the E-stop button, and we can reset the circuit. But if we E-stop and we don't disengage, the reset button does nothing. So this is just an example of a simulation you would do, and we would take this and take it a step further. When we get to V119, this would be implemented on the robot cages. So now we're in L17. L17 is our computer networking lab, and this lab is used by all three of our computer electronics and engineering students. They're in first year for their networking course, but it's also used by the cloud computing program and the computer system technician program. In here, we do a lot of work with hardware, with networking, and embedded controls. So all of our first year students who are in the common computer electronics and electrical program do take networking, and that takes place in this class here. So in this class, we have a fully networked system, as we do in every lab, but has a separate network just for the use of this lab, and it has a bank of hardware, and usually in the back corner, that is used for students to work on teardown and assembly. And if you are in the computer electronics or the computer engineering technician program, you will be spending a lot of time in this room during second year. So this is our radio room, which also has some equipment stored for L18 and L19. The School of Technology, and more precisely our program, Computers, Electronics, and Electrical, we support and facilitate an amateur radio club as well as a student branch of the IEEE, which is the Institute of Electronic and Electrical Engineers. We have the ability to administer the exam for anybody wanting to get their ham radio license. I'm VA3 FDF, and it's just basically another way for students to socialize, to help each other out, and to expand their learning outside of the formal curriculum. So we're in L119A. This is our communications lab. This is used mostly by second and third year electronics engineering technician and technology students. So in here, we are doing various forms of communication, wired and wireless, some fiber optics, and our wireless includes Wi-Fi, Bluetooth, over-the-air signals, including high-definition broadcasts. Also, our students in here are designing and fabricating and testing communications equipment, as well as making their own antennas. So you're going to see in videos later on in this presentation of Professor Filion showing how they are testing their antennas on a vector network analyzer. And we're also going to see the anechoic chamber where they are testing their antennas in an environment that is free of any reflection or bounces of the signals.
Hi, welcome back. This is our electronic antenna lab, and what we have here is a vector network analyzer and a spectrum analyzer. So on this machine, this is actually a student project where students design different antennas, and they actually create them, and then they test these antennas. And when they test them, they put them on the VNA, and what you're seeing here is, and you can see as I touch it, I can change the impedance of the antenna. So students are creating antennas for 2.4 gigahertz for Bluetooth or Wi-Fi applications. With this, I can also change the format and look at a Smith chart, something like this, so you can actually see the reactance of the antenna. We teach students what that means once you get into year 3. This is the spectrum analyzer, and what you're seeing is actually the frequency hopping of Bluetooth. And you may have noticed I'm wearing AirPods. So if I take this antenna and I look at the AirPod, I can actually monitor the 1600 hops per second that Bluetooth is actually doing. And I can actually see the spectrum at which I'm transmitting. I'm just using this as an antenna to pick up the signal.
So this is our anechoic chamber. Anechoic means free from echo and free from reflection. So what happens in here is our electronic students design and fabricate and test antennas. So in this chamber, at the other end, there's a transmitter, and at this end is the antenna that's under test, that is being monitored by this equipment here. So they're able to test their antennas without signals bouncing all over the place. Because in the real world, radio signals, wireless signals bounce off buildings, they bounce off everything. So this anechoic chamber absorbs any of that reflection and bounce. In essence, we are simulating here an infinite sized room where there's nothing for the signals to bounce off of.
Hi, what I'm going to demonstrate to you today is what our year 1 students manufacture in our first term courses. They'll take a blank board such as this, and they're going to populate all the boards with surface mount components. We do this using a screening technique. So we'll deposit solder paste on the board. They'll populate with all the little components, something like this, and then they'll place the board into a reflow oven, such as this. And then this board will go through the reflow oven, and when it comes out of the reflow oven, it will have soldered every single component on the board in about 8 minutes. So there's 1,000 components on this board. The student board looks like this one here. So once the surface mount components have been soldered on the board, then our year 1 students will then learn to do hand soldering, and they will solder all the bottom through-hole components. So this is our solder lab, where students will take their printed circuit boards, and they'll actually populate the the through-hole components on this board. So they will literally do all of the soldering on the bottom side of the board. They'll then inspect every single solder to make sure that everything is correctly assembled, and then we go through the testing process. So in our year 2, we do advanced circuit board manufacturing. This is an example where we have a ceramic substrate, and students actually create a hybrid circuit. So we've got electrical conductor paste and overglaze mounted onto a board. We then segment the boards with a laser. Once the boards are segmented, they'll look more like this size, and then they'll actually do a hybrid assembly using a reflow oven. Now this reflow oven is unique and special. It's got a Teflon conductive belt, so as it goes through the processes, it'll heat and solder all the components onto that ceramic board, going through a cooling stage, and then they'll have their final product once it reaches this stage here. This is a 1 kilohertz generator, and then the student will take this and populate it into a handheld signal generator.
So right now we're in L116, and L116 is where most of the study takes place for year 2 electrical and year 3 electrical engineering technician and technology. So in this room, we cover topics such as power distribution, renewable energies, motors and generators, and what we're getting into, just some of the examples here, is we have a test solar panel for student use, and it does have an inverter and to convert to AC, and it has a battery charge controller. And then at our next station here, we actually have an inverter that ties back to the utility, because what we're getting into here is when you are generating your own power, it has to be sold back to the utility for you to make that, that system pay for itself. So what we do with our students is we get into connecting back to the utility. Also, this station here is where we get into synchronizing generators, because a lot of factories, a lot of industry generate their own power to do what is called peak shaving or peak shifting. And what happens is when you're generating your own power, you want to sell some of that back to the utility if there is extra, or you need to sync with the utility. So what happens is you need to synchronize your generator with the utility, so a lot of that goes on in here. Okay, we also touch into fire suppression systems in here on a building-wide level. We're not talking about a low fire alarm for your house. We're talking about for big buildings. So we get into that, and our apprentice systems, our apprentice programs get into that as well. We also get into motors and generators, which is a big part of the electrical world. So in this room will appeal to students who are looking to get into power generation and power distribution and working with utilities, okay? And also for maintenance at industrial levels. Welcome to L105. In L105, this is where we teach introductory PLC programming, so first level PLCs, as well as our digital systems course takes place in here. So for PLCs, or programmable logic controllers, that is your introduction into industrial automation. So programmable logic controllers read inputs from processes and activate outputs. So for instance, inputs could be detecting that a parcel has arrived at a certain location on a conveyor belt. Activating a process might be just pushing a hydraulic cylinder that has a bar on the end that pushes that package off of the conveyor belt onto another conveyor belt. But there are different things. It could activate robots. It could activate lifts, drops, move into other things, circular tables. But what we do in this lab is we have our programmable logic controllers, and we have a bunch of simulated inputs and outputs that students can hardwire and test themselves. But we also have simulators. What simulators do is we have students program in ladder logic, and we have various simulations that they can run. Okay, so this thing is running. It gives them different angles of the process. They can pan back and forth to see what's going on. They can zoom in, they can zoom out. Okay, and what the students are doing, so in this case, we are stacking boxes 3 high on a pallet. So it's going to come up. And then what we see on here is the students are actually seeing sensors. So when I activate sensors, we can zoom in, okay? We can zoom in here, and they can see when a box arrives, certain sensors turn on. So here's what tells them which sensors are on or off, and this tells them which actuators they turn on. Okay, so actuator 1 actually turns on this belt. Okay, so they know when to turn that on. Sensor 0, sensor 1 tells you when the boxes reach the top, and their program actually goes through and analyzes what's on, what's off. So what it's saying that if sensor 2 and 3 are both on, that there's a box at both, that it's time to start stacking the boxes. Okay, so we actually get into some pretty neat programming, and we've seen students in this class who it really sparks an interest in industrial automation for them. And so we've seen students completely take off into the industrial automation world. So they look for IA co-ops, and they look for industrial automation jobs after graduation. So after this, we're going to go to V112, where we're going to see our advanced PLC class as well as our robotics lab. Welcome to V112. In L105, we showed you the introductory PLC lab. So in V112, we have our advanced PLC lab, and we're also able to network these PLCs together, which does happen in industry. If you have a large manufacturing process going on, they have multiple PLCs, they do talk to each other. And we also take our venture into industrial automation a step further, and we have our robot lab that's been set up here. So we have 7 FANUC robots, and FANUC is a major player in the robot industry. So these are LRMate 200s. These are the actual robots you would see in a factory. They're not little playthings. And FANUC makes robots, all manufacturers do, from 10 kilograms, 2,000 kilograms. They range in size, they range in power. We have these set that they move at 250 millimeters per second when a student is working, or slower if we want. But these robots are capable of moving 2 meters per second, or 2,000 millimeters per second. Okay, so it's 6 feet per second. If you start doing the math, that's pretty fast. And when they actually do move that quickly, you actually have to bolt the robot into the ground, because it will shake whatever it is you're working on. So our students go through this. Every student that graduates from electrical and electronics engineering technology will also receive certification from FANUC as material handling and robot programming certificate. So there are 3 of us at the college who are certified to teach this course. So you will have extra certification when you do graduate from Niagara. So we also pride ourselves on having a do-it-yourself attitude at the college. So even though we have these $60,000 robots, we still enjoy making things ourselves. So these grippers on these robots, for example, have been done on 3D printers, as well as the grippers that we have for the labs that we do that involve holding the dry erase markers. So our 3D printers do get a workout at the college. We do a lot of prototyping, and we do a lot of do-it-yourself. So nothing is really impossible. If the student can think of it, we can find a way to make it. So right now we're in central supply, which is in the back of L18 and L119. And in here we have 4 full-time technologists who are Niagara College grads, as well as 2 co-op students from the technology program. And from this room, they maintain and support all of the labs that we're going through today. And they also support our students who may need help in labs. A lot of them take on lab sections as instructors. So pretty much everybody who comes through our program knows all the technologists' names and vice versa. Also from here, we prepare the parts kits that go out to our students. The technologists also help get labs ready for the professors. And it's just a nice symbiotic relationship we have with them where the students benefit on many fronts.